Right now we're going to do a lesson on square roots, actually radicals, many different types of roots, maybe third roots, fourth roots, but of course square roots as well. We kind of already seen these notes before. We should know how to simplify radicals, but right now let's begin with something else, and you might want to jot this down in your notebook if you'd like. What is a square root really? It's actually a rational exponent. Right? What is a rational exponent? It's an exponent that's a fraction, right? A rational number is a fraction. So a square root is really the power of 1/2. Just like the third root is really the power of 1/3. Or the fourth root is really the power of 1/4. Did we already know this? Yes, I hope. And if not, well, now you know. It doesn't matter what kind of root you have, it will end up being the power of 1 over that root. So, as an example, we already know that the square root of 9 is 3, right? If I wanted to, I could take this 9 and manipulate it, rewrite it as 3 squared. That way I could apply that rule of the exponents, that when you have a power to a power, you'd multiply them. And 2 times half is really just 1. So you'd have 3 to the 1, which is really just 3. Now I know you're thinking, why the heck would I want to do that if I already know that the square root of 9 is 3? On this section, we're going to have to be able to manipulate radicals to rational exponents. Now, let's actually take this a step further. The meat and potatoes of today's lesson is that you're going to be able to take any radical with whatever base you have in here and whatever power you have right here and whatever root you have right here. And you're going to be able to take that radical, doesn't matter if it's a third root, fourth root, or any type of root, you're going to be able to take that radical and rewrite it as that base to the power of a certain fraction. And that certain fraction will be the power over the root. This is what we have to memorize today. This is the most important part of today, right? So when you have any type of root with any type of term here to whatever power, you could take that term, write it, and it's going to be the power as a numerator of the fraction that's your exponent, and the root's going to be the denominator of the fraction that's your exponent. Okay? What do you guys think? So if I wanted to, like we already know that the square root of 9 is 3. But check out how I could manipulate this. This 9, I could rewrite it as 3 squared. And it's a square root. There's an invisible 2 out here for the square root. So technically, I have 3 to the power, which is 2, over the root, which is 2. So that's really 3 to the 2 halves, which is really 3 to the 1, which is really just 3. That's why the square root of 9 is just 3. I know you're thinking, I'm never going to do that. I already know the square root of 9 is 3. I'll just say that the square root of 9 is 3. Yeah, that's true. But on this handout, on these notes, we're going to be simplifying terms that have powers and roots. And it doesn't matter if the power is on the inside of the radical or the outside of the radical. It doesn't matter if it's on the inside or the outside. The power will always be the numerator of your rational exponent. The root will always be the denominator of your rational exponent. So this guy right here, it's in radical form. If I wanted to simplify it, let's use what we just learned and write this as that base to the power of what over what? What's the rational exponent that I need to put on this x? That's right, the power of 8 over the root 4. So power of 8 over the root 4. So what's your final answer really? What's 8 divided by 4? 2. X to the second is your answer. So this complicated looking problem, once you understand that it's that base to the power over the root? Simple answer, x squared. Okay? Now, these notes are written right here. It says fact. Any type of radical, doesn't matter what base you have, what power you have, and what root you have, and it doesn't even matter if the power is on the inside of the radical or the outside of the radical, it's always going to be equal to that base to a rational exponent, fraction as an exponent, and the numerator of that rational exponent is the power, whether it's inside or outside, that's the numerator, and the denominator of the exponent is going to be the root. Okay? So let's simplify any of these. Like let's say, actually let's go down here, step at a time. Right here, if I know that it's going to be the power over the root, then that's really going to be x to the what? 6 over 2. So what's 6 over 2? So that's just x to the third. Boom, done. Easy peasy, right? Now, I'm going to be skipping over these guys because whenever you have a number, you could actually use the Casio calculator and it'll do it for you. Okay, so I just got asked a good question. Where do we get the root 2 from? A square root, they never write it, but there's really an invisible 2 right there. Now, if there is a 3, then it's not a square root anymore. It's a third root. It's a fourth root. But if they don't write it, it's kind of like me saying what variable or what's the leading coefficient right here in front of x? Oh, there's an invisible 1, right? Even though you don't see it, you know it's there. Right here, you don't see the square root, but it really is a square root if they don't put an actual number there. Good question. All right, so let's go to number 4. Because see, the Casio calculator can't simplify radicals that has variables in it. So let's go to number 4. And I do want to go through this process. There's many different ways of doing this problem, but I do want to practice this process of changing x to be the power over the root. What power do we have? 3. And what root do we have? 2. Okay. That's really x to the 3 divided by 2. What is 3 divided by 2? 1 and 1/2, right? 1.5, which is 1 and 1/2. So let's actually write that as x to the 1 and 1/2 power. So I'm about to do a little trick right here that I want you guys to really understand and be able to apply, not only in this class, but all of next week. We're going to have to use this little trick. And the trick that I'm about to use is actually rule 1 of exponents, but backwards. What do I mean by that? Rule 1 of exponents says that if you have x to the second times x to the third, what do you do with those exponents? Add, right? Okay. So yeah, when the bases are the same, you could just add the 2 and the 3 to get 5, right? That's rule 1 of exponents. We should have learned that in Algebra 1. But anyway, we're going to use that rule backwards right here on this guy. Because it says x to the 1.5. So it's kind of like we're going to make that 1 and that half separate. We're going to take this base x and we're going to write it 2 times. X. This 1, we're going to put it on the first x. And this 1/2, we're going to put it on the second. So what is x to the 1? That's just x. And what is x to the half? Well, if you can't really do it, might as well rewrite it back in radical form, square root of x. We know that the power of 1/2 is a square root of x. So there's your answer for the square root of x to the third. That's definitely not the quickest, easiest way to think about this, but it's a certain way that I do want you to practice. What's the quickest, easiest way of thinking about it? Well, since the square root of 2 is really the power of 1/2, you would want this to be divisible by 2. So you could have rewritten it as x squared times x, and then you could have split that root. And of course, the square root of x squared, that's just x, and the square root of x would stay. See how it's the same exact answer? But I do want you to practice this, changing an improper fraction as the exponent into a mixed number that's an exponent, and then splitting the base using rule 1 backwards. What do I say rule 1 backwards? Because if I actually did multiply x to the 1 times x to the half, that would take me back to the x to the 1.5. So I'm using rule 1 backwards to split the base and have x to the 1 and x to the half. Okay, that's just a little trick that we're going to have to be using in the future many times. Let's go up here to this practice up here. like I said, the numbers you could easily do on your calculator. 5 through 9, pick one on 5 through 9. All of these are variables. Which one do you want to do? 8. Okay, so if we look at 8, power over root, what are we going to have? X to the 7 over 2. All right, so what is 7 divided by 2? 3.5 or 3.5, right? And let's use that trick, rule 1 of exponents backwards, where you take the base x, write it twice, put the 3 on the first one, and the 1/2 on the second one, and you're done. All you got to do is change that power of 1/2 back to a square root. So your final answer is x to the 3rd square root of x. Again, the trick is to be able to change this and split it into x to the 3rd and then x to the 1/2. Because if you were to actually multiply these guys, you're going to add 3.5 together, you get 3.5. So it's using rule 1 of exponents backwards to split it. And x to the 3rd is simply x to the 3rd, and x to the 1/2 takes you back to the square root of x. Now, on certain tests or quizzes, if they say leave your answer in exponential form, then you would leave it like this, x to the 3rd times x to the 1/2. And again, some might say rewrite it in radical form, so you want the root. So it's the same correct answer, just written in different ways. Okay. All of these, well, especially the even ones, are ridiculously easy, because when you say x to the power over root, 4 divided by 2 is 2, x squared. You're done, right? Let's do number 9. So let's write it as a power over root. What do I write? X to the 17 over 2. And what is 17 divided by 2? X to the 8 and 1/2 power, right? So let's split the base, and what do I have? X to the 8 times x to the 1/2. Now, if they said write it in exponential form, that's your answer right there. Now, if you see on a multiple choice that you have radicals, so what's our answer going to be in radical form? X to the 8th times square root of x. So this is good, but it all depends on what answer is shown to you or what they're asking you for, in exponential form or in radical form. Let's jump to something more fun, like, I don't know, 16 or 17? 17, okay. So on any radical, it doesn't matter if it's a square root, cube root, fourth root, whenever you have pure multiplication on the inside, like we do here, you could split the radical to each of those items. So you have the square root of -9, you have the square root of x to the 4th, you have the square root of y to the 3rd. What's the square root of -9? 3i, right? 3i. Hope we remember that. And how about when we think power over root, what answer we get right here? Power over root. X to the 2, right? Power is 4, the root is 2, 4 divided by 2 is 2, right? Power 4, root 2, 4 divided by 2, it's power over root, so that'll give you 4 divided by 2 is 2. Last one, this one's going to require some work on the side, so I want to take this y to the square root of y to the 3rd, I want to rewrite it as y to the power over root. 3 divided by 2 is what? 1 and 1/2. And I'm going to split the base using rule 1 of exponents backwards. Y to the 1 times y to the 1/2. So this y to the 1, that's a nice beautiful y. I want to put it as part of my answer. And y to the 1/2, what does that become? Square root of y. So this is your answer right here in blue. The only other thing you could do, or that you might see different, is the I is probably not going to be behind the 3. They might put the I between the y and the square root right here, or they might even put it way out here. So 3x squared y I squared of y. Or maybe they put the I out here at the end.
Why would they put the I in between y and the square root of y?
All right, pick one of these.
26.
26. We'll do, all right, 24 and 26. 24. What are we going to do first? You have that radical. What do? Split it up, right? It's all pure multiplication. Let's split it up. So what is the third root of 8? That one's easy. Yep. So the third root of 8, this guy is 2. Nice, beautiful 2. That's going to be out in the front. How about when I think x to the power over root? Power over root. What do I get as an answer? X to the... guys, we know how to divide, right? Yeah. To the second, right? 6 power, 6 divided by the root 3. Power over root, that becomes 2. And now let me ask you this. Could I divide 2 by 3? No. So you could write it as y to the 2/3, power over root, but that's not really going to help you, especially if our answers, we usually switch them back to roots, right? So let's just leave this guy alone for a while. But over here, when I go power over root, what kind of z do we get? Z to the 3rd, right? Power over root. 9 divided by 3 is 3. And this guy we weren't able to do, so let's just bring it down. The 3rd root of y squared. And that's your final answer right there. Let's jump to number 26. Fun stuff. There are many ways of doing this problem. Many ways. I'm going to look at it with this power 2 over this root 4. So I'm going to keep the power of 6 on the outside, and I'm going to just work on the inside right here. So what do I have? X to the what? When I have the power of 2 over the root 4. Power of 2 over the root 4 is 2/4, and that is not 2. That reduces down to what? 1/2. So I might as well rewrite that as my reduced fraction 1/2. Now I could change this to the radical, but what's the point of that? I could multiply power to a power. So what's 1/2 times 6? 3. So there's your answer. X to the 3rd. Could it have been done differently? Yes, there's many different ways of doing it, but I think that's pretty good. Any other one? Which one? 23. All right. So this time we have a binomial, but we still have a power and we still have a root. So let's start with that. We have the binomial what? X plus 3 to what power? Power over root. What do you get?
8 over 4.
8 over 4. Now, what is 8 over 4 really? That's really just 8 divided by 4 is 2. So we really have x plus 3 to the power of 2. So if you see that that's your answer on a multiple choice test, you're done. But you might not see that. They might actually take that x plus 3 and actually multiply it with itself 2 times, distribute x squared plus 3x plus 3x plus 9, x squared plus 6x plus 9 is your final answer. But I don't know if they're going to write it as a quadratic trinomial or leave it as a binomial squared. Either way, the main idea here is to remember that you have a power over your root. 8 divided by 4 is the power 2. 29 or 30? Either one. Okay, I'll do 30, you do 29. That's ridiculous. It's the same question. I'm sorry. Typo. Whatever. You can scratch out 29. We're going to do 30 together. I have a square root with a fraction inside the root. I could split that root. So we're really going to be working on 2 separate problems in one. You have the square root of 9, x to the 4th, z to the 5th, and you're going to have the square root of 25, z to the 7th. You know what? I'm making a mistake already. Before separating the root, you're supposed to look at the inside and see if you could do anything. I have a fraction. Could I reduce anything on that fraction? Could I cancel anything on that fraction? Yeah, what could I cancel? The z's. So let's go back and let's cancel those z's. It'll make it way easier. Z to the 5th, all 5 z's completely cancel with 5 of these 7, and I'll have 2 z's left over on the bottom. Way easier. So when I split it, I'll have 9x to the 4th over the square root of 25 z to the 2nd. So the one on top, when you split that root, the square root of 9, square root of x to the 4th, but we already know that the square root of 9 is 3, and we have a power over a root. What x are we going to have? X to the what? X to the second, x squared, that's right. So on the numerator, on our answer, we have 3x squared. Now let's do the same for the denominator. When I split square root of 25, I'm just going to do this in my head. What's my answer? 5. And the square root of z squared, what do I get? Z. Ta-da. I almost made the same mistake I made on the previous class. I did not cancel those z's. If you don't cancel those z's, it's a whole heck of a lot more complicated. Either way, that's what we're doing today. We're just practicing this main point, this main fact, that whenever you have any radical, any power, it's simply going to be that base with the power over the root. Here it is. Base with the power over the root. And this is a rational exponent, an exponent that's a fraction. All right, we're done here.